Hello, my name is Philip. I'm a postdoc at the Adapt Centre, Technological University Dublin. I'm a white male, use he/him pronouns, have brown hair styled in a messy fringe, currently wearing glasses and a red checkered shirt, and today I'll be presenting my recent paper titled Idioms, Probing and Dangerous Things Towards Structural Probing for Idiomaticity in Vector Space. I point out that this work finds itself at a crossroads between about three different disciplines. So our research questions and our motivations are sort of in this space, right, on the crossroads of these three disciplines. And some of the questions we ask are how is idiomaticity structurally encoded in vector space? Does the vector norm play a role in encoding idiomatic information? And is idiomatic usage encoded similarly to contextual incongruity, which we hypothesize it might be? The approach that we take is we simply apply the probing framework, specifically a flavor of it called probing with noise. We repurpose an existing idiom dataset into a probing dataset in order to be used in such a way and allow us to examine structural properties of a static and contextual encoder and trying to identify where idiomaticity is stored in embeddings. So what is probing, and more specifically what is probing with noise? A typical probing pipeline looks like this. You choose a linguistic property of interest, such as verb tense. You choose or design an appropriate dataset that properly describes and captures this phenomenon. You choose a word or a sentence representation, such as BERT. You choose a probing classifier, which in this framework is called the probe. This can be an MLP or SVM or anything else. And then you train the probe on the embeddings as input. Once you evaluate the probe's performance of the task, you can sort of make inferences in terms of whether the probed knowledge is encoded in the representation or not. This is where typically the probing framework stops. However, we've added a few steps in our previous work that allow us to sort of obtain structural insights into the embeddings as well. So instead of stopping at step 6, we consider it a vanilla baseline and then introduce systematic noise in the embedding, the goal of which is to disrupt the encoding and actually remove or ablate the information from one of the vector's components. And then once we've done this, we repeat the training and evaluate again and compare the evaluation. The idea is that if the performance is dropped, that means we've removed relevant information. So it's a sort of ablational method, really. One concept that helped us in thinking about this is the idea of information containers. Because embeddings are essentially vectors positioned in a shared multidimensional space, and they're defined geometrically by their direction and their magnitude. The direction being the coordinates in the space that the vector points towards, defined by its dimension values, and the magnitude being the length of the vector defined by the vector norm. In previous work, we've shown that these two components of a vector, so the dimensions and the norm, can and are actually separate information containers. And our method is able to distinguish their contribution to encoding the types of information. So using probing with noise, we can find out whether idiomaticity, for example, is encoded just in the dimensions of a vector, just in the norm, or in both. Other than this being an interesting structural insight into embeddings, why is this important? Well, because the norm is often disregarded in the literature, and many approaches that are sort of commonplace rely on things like normalization of the vector, which removes information from the norm. So imagine if we did a cosine similarity between, as illustrated here, the vector for Apple, which is very short, and the vector for New York, which is quite long. Imagine if they were pointing in this exact same direction, and we calculated a cosine similarity, we would conclude that they are identical, completely disregarding the differences in their norms. So with the capabilities of measuring these differences, we want to see where is idiomaticity encoded in embeddings. In order to do this, we need a probing dataset and a well-defined probing task, which needs to ask a simple, non-ambiguous question. And when we're probing for idiomatic usage, we need a task that can directly tease out idiomaticity. We require sentence-level instances so that we can sort of model the context surrounding the idioms as well. And we require the same idiomatic phrase to be used both literally and idiomatically in the dataset so that the model can learn the differences. One existing dataset that sort of matches these descriptions is the VNC tokens dataset, which is an English verb-noun idiomatic combinations dataset containing idiomatic phrases such as hit the road, pull the plug, make a mark, etc. Now, it is very important to choose the correct train and test split for this task, because we really want to avoid lexical memorization. We want the model and the probe to learn the difference between literal and idiomatic usage in a sort of abstract way. So to kind of help it along, the choice of train and test split is very important. And we tackle this on two fronts. In the test set, we make sure that the model's performance is tested only on idioms it has never been trained on before, so on the phrase level specifically. And we also make sure not just the phrases, but also the verbs themselves, the verbal constituents, which arguably are quite important, do not show up in the train set as well. On the other hand, when it comes to the train set, we want to make sure that the verbal constituents repeat. So notice that all the idiomatic phrases that are contained in the training set, the verbal constituents repeat at least once, if not more. That way we kind of diminish the impact and the importance of the verb, and it's not really used as a signal to the model. When it comes to our experiments, we chose two embedding models, one static, i.e. glove, and one contextual, i.e. BERT. Both off the shelf, and notably, again, we did no fine-tuning on these. So they're not specialized for the task. They are just used as is, because we're trying to sort of get at how much idiomatic knowledge is already contained in them before they're specialized for a task. For our probe, we chose a multi-layered perceptron and defined the problem as a binary classification task. For evaluation metric, we used the AUC-ROC score, which is well suited for imbalanced data sets. When it comes to our results, we can see that glove in its vanilla version outperforms the random baselines, meaning that it encodes some sort of idiomaticity somewhere in the embeddings. We don't know where yet. And when it comes to BERT, it is also outperforming the random baselines, and in fact also outperforms glove, meaning that BERT encodes more idiomatic usage information than glove does, which isn't surprising because BERT is a contextual encoder. Now, when we apply our probing with noise method and ablate first the norm information, then the dimension information, then both, we sort of see that there are no significant differences, and this is sort of the key takeaway. Like, if you ablate all the dimension information and the only thing left is the norm, and you're already performing akin to random baselines, that means there's nothing in the norm that is relevant to the task at hand. So based on these results, the norm does not seem to encode any idiomaticity information, which we find a bit surprising because we did expect it to behave sort of similar to contextual incongruity tasks, which we found in the past do, especially in BERT, encode this information in the norm of the vector. So we thought, oh, maybe BERT encodes contextual information in the norm. This doesn't seem to be the case, and we can take this at face value, but we wanted to better understand the relationship here, so we ran a few more post hoc analyses, and we found some interesting things. First, we ran a Pearson correlation study between the vector norm lengths and the class labels, where we found that in the vanilla vectors, the glove and BERT, both norms have a weak negative correlation with the idiomatic usage labels. However, when we apply our probing with noise norm ablation function, which is meant to remove all information from the norm, we find that the correlation drops to 0 when ablating information, indicating some information has been lost. So this hints that some idiomatic usage information is encoded in the norm of these vectors, which doesn't align with what we just found in the experimental results. If we look at this at face value as well, we can see that this negative correlation means that sentences containing idiomatic usage are positioned closer to the origin of the vector space, meaning that idiomatic vectors are slightly shorter, which is an interesting structural finding. But okay, let's assume our first set of results is correct, and all of the idiomatic usage information is stored in the dimensions of the vectors. Let us find out where. Let us try to ascertain some sort of degree of localization. So we come up with this little experiment called dimension deletion, where we essentially just delete half of each vector in the data set, first the first half, then the second half, and assess the impact of this on the probe's performance. Obviously, deleting half of the vector's dimensions should cause a significant drop in performance, and this should happen regardless of which half of the vector is deleted. Interestingly, when we look at glove first, we can see that deleting the second half of the vector does drop performance, but not as much as we might expect. Like, there's still quite a bit. However, deleting the first half of the vector shockingly increases performance in one of the glove scenarios. We might chalk this up to like a weird, property of this data split, but we see the same thing in BERT as well, and the performance increase is statistically significant. So somehow deleting the first half of the vector, like losing half of the information for this task, somehow means we get better at the task, which is in no way should be the case. and is a bit baffling. Unfortunately, we cannot really make sense of these results, which isn't very satisfying, but we have a theory as to why this may be. Having done all these experiments and seen all these very strange behaviors, we suspect that maybe the dataset itself is to blame. It is possible that the VNC tokens dataset is not really ideally suited to a probing scenario. First of all, it is quite small. It is 2 orders of magnitude smaller than established datasets. It's limited in scope and focuses only on one subtype of idiomatic phrases. It's a relatively older benchmark, so it may not have been as meticulously crafted as more recent datasets. It's also imbalanced in terms of idiomatic and literal usage, and does not control for things like sentence length. Also contains quite niche literary language and even the occasional typo. So in spite of all our efforts in trying to mitigate confounders and trying to massage the dataset into becoming a probing dataset, it seems like it just isn't. However, to confirm this, we would also love to actually concatenate this dataset with other existing datasets and sort of try to see whether our findings hold both larger number of samples and larger variety of idiomatic phrases. So in conclusion, to recap, both Glove and BERT encode some idiomatic information to varying degrees. BERT encodes more than Glove. And both Glove and BERT store idiomatic information in the dimensions of the vectors and specifically localize them in the second half of their vector dimensions, which is arbitrary and strange. The first half, in fact, seems to be detrimental to the vector's overall encoding of the task at hand. And it seems, as far as the norm is concerned, our experiments yield inconclusive evidence as to whether idiomaticity is encoded in the vector norm. But we present all this with the caveat that this is all on this one data set, which does have some limitations and probably needs to be adjusted in order to be used with the probing framework. So as far as we're concerned, whether the norm can encode idiomatic usage information is still an open question and certainly warrants further research. Thank you so much for your time and attention. I take any questions you have in any of these communication channels. Feel free to reach out. I'm happy to chat. Thank you.